Okay, well that finished, and we can quickly print here to see this is just as before, the first training prompt. Actually, let's go back to the 0 training item and see what that looks like. This is the interior knob, and here it is. This is the prompt. This is the completion, rounded to the nearest dollar. If we go instead to the 0 test item, we'll see the prompt and the completion. Again, these are the two columns that Hugging Face expects. And you'll see there is the prompt, there is the completion. Let's now just look at the whole of the distribution of tokens in this so that we see whether or not we are cutting off. We hope to be cutting off at such a point that with a little buffer, we can be using maximum sequence length of 128 for a power of 2. Let's see. Okay, it's finished. Let's have a look. Here is our chart, the average 101. And good news, the highest is 126. We can use a maximum sequence length of 128 and feel good about our power of 2. And this will now upload that to Hugging Face and we will be in great shape. So we have now produced two data sets. One is called items prompts light and one is called items prompts full. These data sets, they only have two columns. They have prompt and they have completion. And that is exactly what Hugging Face expects. And next, we're going to go back to Colab and check out what these data sets look like. And sorry, before we look in Colab, let's look in Hugging Face at these two data sets we just uploaded. Start with light. So this is it in Hugging Face. You'll see that it is, first of all, it's something which has 3 data sets. It's got a split of train, val, and test. 20,000, 1,000, and 1,000. So that means it's 22,000 rows in total. This is what it looks like. It has a prompt and a completion. The prompt is things like, what does this cost to the nearest dollar? Title, category, description, brand. That's the prompt. The completion, this prompt ends with price is dollars. And we're training a model to complete this, to give the next tokens, and we want it to complete it with the tokens for 64.00. And the reason that we're rounding everything up again is because we don't want to distract the model trying to predict numbers of cents. We'll just focus it on this, which conveniently, in the case of LLaMA, will always be one token. Everything from 0 to 999 will just be, or 1 to 1999 will just be the single token. That's perfect. That's the light data set. And if I look at the test data set, presumably, we'll see in here that it's the same, except in the case of the test data set, we do in fact have the real numbers so that when we're testing, we get that right. So that is the light data set. And if I come into the full data set, here it is. It's bigger. It's got 800,000 rows, 10,000, 10,000, and you can see the total number of rows, 820, but otherwise everything is the same. It all looks great. That's what we've been doing. We've uploaded this data set perfect for fine-tuning. This is how you would do it too for fine-tuning for your task. Okay, we are now going to open up Google Colab and let's come in to week 7, day 2 of The Price is Right. So we have to first start by connecting to a T4. Again, a free T4 box. Be sure it's a T4. Be sure you've got the right one. Make sure you've got the GPU. Come here and do a view resources. Otherwise, things aren't going to work. Make sure you got the GPU RAM in there. Excellent. So, as always, we start by doing the bits and bytes pip install. Otherwise, you'll get problems later. So be sure that you've done that. There's also this curious line here. Look at this. What is this doing? wget -q and then a whole lot of stuff with my name in it. What is this with something called util.py? Well, so what I've got is I've written a little utility class and running that, I've put it in the week 7 folder in GitHub, and this just downloads it onto this Colab, and it saves me having to have tons of code in here. But it's the same evaluator thing so that we can have that cool graphic and not have to have retype all of the code every time. So in fact, in Colab, there's this little file icon here. If you go there, basically it's just downloaded this file util.py and plonked it right there. You could open this up and look at it, but you would find that util.py, is there a way that we can view it right here? Not that I can see, but I'm sure there's a way that you could get, oh, there we go, double click. Who knew? Double click on it and we see this file and you might recognize this. It is in fact the same evaluator as before. And that's going to mean, close that down, that we can do some imports. And one of our imports here is from util import evaluate. That's going to let us do our evaluation. Lovely. So we're doing some imports, and now we have a few constants. This is the base model we're going to be using. The project name is going to be the name price. That's going to be something that we'll be using. I've got light mode is false right here, but actually I don't think it's going to matter for this one. So I'll make this true for now. That should be absolutely fine. And then we're going to load in the data, picking the right data set. So this is very familiar code for you, I hope, because it's basically the same that we are used to. And that ran so fast, probably because I've already run it in the past. Oh no, because it's just the constants. We haven't loaded anything yet. We first have to log in to Hugging Face. So you have to make sure that you've got your Hugging Face token set and that tick is yes. And now we log in and it logged in. And now we load our data. So we load in our data set and we separate out the train, the validation and the test data, loading in. This is the one that actually is not going to be that quick because I haven't done it in advance, but it's quick because it's a small data set. And we'll print the first test item and check this out. It's just what we would hope. It's a dictionary with two fields, prompt and completion. What does this cost to the nearest dollar? Our favorite V2 distortion noise pedal. If you ever needed one of them, now you know all about it. And it costs a wonderful $219. There it is. Let's just do test number 1. There it is. And let's do train at number 0. And we're expecting to see that it's nicely rounded 64.00, which is the interior knob. Another thing that you always wanted. Okay, so now we are going to say we would like to have 4-bit quantization. So let's set our quant config right here. And we're going to load in our tokenizer. This is basically the same code as before. I don't know if you remember from week 3, there's this fiddly stuff that you have to do when you tell it the pad token should be the same as the end of sentence token and padding side should be right. You don't worry about this. You just always do this. You just always use this code whenever you load in a tokenizer for this kind of purpose. It's just the standard stuff. If you don't do it, you just get a few warnings, which is annoying. I don't think it actually interferes with anything. And so you always see the code like this. And at the end of it, we'll print the size of it again. We're looking for that same number as before. We're expecting to see, what was it, 2.2 gigabytes? That should be the size of the quantized LLaMA. I think it was 2.2 before we added in the LoRa matrices. So this will load in. This is going to take 30 seconds or maybe a minute. And when it's done, I'll be right back. Okay, it just loaded in. It is 2.2 gigabytes. I remembered right. Okay, then here's a new function for you. It's called model predict, taking an item. And this is something which is going to take our base LLaMA 3.2 model, quantized down to 4 bits, and we are going to try to predict. We're going to predict what is the result of asking it to complete, to predict the next token that comes after that input. Right off the bat, no fine tuning, just as it is. So basically we take the inputs, we take the prompt column of an item. Remember, that's the thing up to the price is dollars. And we put that on, Takuda puts it on the GPU. And then with torch.nograd, you might remember that from our neural network experiment. This means that we're not going to do any training. We just want it to be in inference mode. Base model.generate, saying we want you to produce the next token, given the inputs, and produce up to 8 new tokens, just in case it comes up with something first before the actual number. We'll give it an opportunity. And then we will turn that, we will pluck out of it just what it generated, the new stuff, and we will convert that from being tokens back into being letters again. And that is model predict. Okay, so with that, let's run this. We're going to we'll first look at what is the first test item, in case you have forgotten. The first test item is, in fact, the blood noise distortion pedal that actually costs $219. So what we're now going to do is we're going to call a quantized LLaMA 3.2 model to complete this. It's going to be given this prompt. It's going to be asked to predict what are the tokens to come after this. And we will see what we get. This is what we get. Drum roll, please. We get 349.99. What is the price? So maybe it was because what is the price that you have or something? It wants to keep talking. But that's what it told us. 349. It was in the right vague territory, but it was pretty far off. That is base LLaMA. Okay, this is interesting. So now we're going to run evaluate. We're going to run the cool evaluate utility to see what this does. But first, I have one more sidebar. That's one more super important thing to explain to you.